I am live. Cool. Hi. We finished off, was it yesterday? I can't remember now. Yeah, it must have been. Finally, we came up with a way to start adding like some basic tests to our package. It's tricky because we don't really have a way to, well, we don't have any known like good RTP packets that we can save to disk that can be run when we run go test. Or rather, that can be like encoded or decoded when we run go test. The way we were testing before was we would have our, we had Big Rock Bunny, and then we would actually, with ffmpeg, we would then send that to, what were we doing? Yeah, we were actually sending that to, wait. Our package, so let's call that, you know. And then from there, we were then going to VLC. So these bits here, 5? Oh. So this was RTP, and this was RTP. And all we were doing was we were just testing that the packets going in were the same as the packets going out. So we're just doing a checksum on the bytes. That worked because we were able to at least get our package to like a state where we go, oh yeah, okay, like it seems to be, you know, it's like doing what we expect it to. The thing is that that's a pretty slow process. So we've got a whole bunch of dependencies on some, you know, pretty large pieces of software. We've got ffmpeg that we need to run, and we've got VLC we need to run. I guess we could pipe it from ffmpeg also through our package and into ffmpeg again. That would be pretty much the same, but it was good to see like, you know, the footage in a different player and stuff. But yeah, of course, the issue is that like this is pretty manual. Yeah, we could automate it, but then like the thing becomes quite complicated. Of course, ideally we'd have something that we can just run by Go's own, you know, testing, like sort of a test framework, test runner. Issue is that we don't really want to, well, rather, we don't know how to take this Big Black Bunny, which is actually an mpeg transport stream, and then we don't know how to pack that into a RTP payload. That requires more code and more like spec reading that we just haven't done yet. So I came up with an idea instead to use a text payload, which is actually supported. And we can actually make some RTP packets. Those are really easy to define because we already have a struct for the packet. We have a struct for the header, and the body, well, that's super easy, right? It's literally just like the literal, you know, byte array, you know, like some UTF-8 characters. That's fine. That's what the payload is. That's super easy to define in code. The issue is that how do we know that we're also encoding them? Okay, rather, yeah, how do we know that we're encoding the packets out again? I don't know something that can like receive text over RTP. So my idea is to actually make I'm going to call it a fake thing. Like this. And this thing is going to be like a player that is going to do some of the job that VLC will do. For example, if we look at our docs, let's have a look at the packet and see what a, like a reader of RTP streams will actually need to do. So the payload, okay, is just a bunch of bytes. So yep, well, that's up to the implementation, of the actual payload. We're just doing text, so, but a player needs to kind of look at all this stuff and make sure that everything's okay. It expects certain things. It expects that for each packet it receives, it's going to have, things are going to be incremented by 1 in this field here. The timestamp needs to be incremented at the appropriate sort of rate. The sync source needs to remain constant. These things we're not dealing with for our basic text thing, but it'll be the same thing. Extension, don't think we're ever going to use that. But yeah. So what we're going to do is we're just going to write a thing that something that could be connected to. So this fake thing is going to have a UDP listener. It's going to read in RTP packets, try and decode them, and see if everything kind of makes sense. That's it. We have some code. Here's our fake player. So there's our packet connection. So that's going to be, in our case, it's going to be a UDP listener. We could also use a Unix gram. Yeah, we could use like a Unix socket or something, but yeah, it's fine. So the main loop is going to be about it reading some bytes from the connection, trying to decode the things, and then check them as it goes. Yeah, that's pretty much it. So I've written some code, but yeah, that's actually where we got up to. The important thing here is that the player, we need to make sure that the player is implemented in a way that it really doesn't care about how the source is implemented. So what that means is that our session type, our session data structure, this transmit method, it shouldn't know anything about that. So yeah, we want to make sure that this thing, this thing in theory should be able to read, like packets sent from FFmpeg. Our player doesn't do anything with the payload, it just throws it away. Well, at least in our case, we can check the payload is the text that we expect, something like that. But for the most part, yeah, it just throws it away. We're just checking for the RTP part. Yeah. I think that makes sense. Hopefully that explanation is helpful, useful. Hope it's sort of at least a bit accurate to what's in my head, and accurate at least to how the spec works. I think it should be okay. But yeah, we need to get the thing to compile first, because we wrote this just at the end of the day last time we were live. Yeah, so let's see. Oh, hey, so Anonymous, I checked out Acme the other day. It's pretty cool, to be honest. Thanks. Yeah, it is. It is cool. It's it's not for everybody, but nothing is. It's got a few interesting ideas that are useful for any kind of programming environment, I think. All right. As I said, let's get this thing running. Okay, so we'll sort of review how it works in here. I can't quite remember, but hopefully if the code sort of works, it should be okay. As packet value, okay, dereference, fake play redeclared. Oh yeah, okay, that's from before. Player declared and not used. Just do that for now. Yeah, the motivation behind doing this is that we actually had some, like we built a thing that, transmitted one packet, received it, and decoded it again just to make sure that everything was all right. That works, but the code is kind of gross, and it, I don't know, I didn't like how, I don't know, it wasn't gross, I just think the way it's written in one big sort of in steps like that is, I feel like it's too close to how the transmitter is implemented. Like I think for some reason I felt like it knew too much. When we write it out in a player like this, it sort of makes it clear that, hey, like this thing, all it's doing is reading from a net.packetcon. It doesn't know anything else. In our test, we're going to set up a fake player and set up a UDP listener and just have it listening on a random port and, whatever. And, every time we run the test, it'll be random. So, yeah. Yeah. Okay. Right, yeah, okay. Maybe what we could do is almost first, yeah, see, and I know, and okay, now the other big motivation for, coming up with this thing is that I just, for some reason, I kept getting confused by this because we had like packets and headers in the first and the second and I just got lost. Feel like we want to do is almost just comment out this whole test for now, and then just maybe come back to it, maybe not. Let's just do another one. Now, how do we set up a player? Oh, we're just going to have to do it like manually because it's only in the tests, so it's fine. We'll grab all this stuff. So now we can actually do that. Player. Okay. So what we're going to do is where is it going to get packets from? We'll have to make them. So why don't we have a function that, what we're looking at is this bit. Show how to make a bunch of, RTP packets. We could actually, what we could do is make a channel that, okay, I got it. Let's, rather than that, let's make a like that, and then we can have something send packets through there, and then this one will receive from it. So let's have that here. And then here we can just have a, like, you know, text packet, you know, yeah. Let's make a little packet. Version marker, yeah, okay. So the type. Marker sequence. Why don't we have a thing that maybe sends like the current time as a text string or something like that? Yeah, let's do that. So let's get it to send through the time. So our payload here is going to be I'll just do the or even we could do like even something simple, you know, the kitchen time or something. Okay too. The old kitchen time. Where is it? Kitchen, yeah. Although maybe we actually want something like RFC. Yeah, maybe let's actually do that, because then we can see the nanoseconds, which we will care about. Now our packet type, or sorry, our payload type is dynamic. So we actually have a little function for that. So a dynamic payload type is randomly assigned from certain values. So we just have a little one was our equals the that, and we only want to set that once. We can't change it throughout. So we'll do that. So the type here is going to be that, and everything else I'm pretty sure is set automatically. Marker, type, timestamp, sync source, contrib source. Yeah, no, none of that. Okay, so that's it. So we don't need that. We'll just do it like that. Payload is there. Like that. Okay, so that'll send one packet. Let's do maybe let's do a ticker that sends, yeah, let's make a new ticker that sends this packet every, or like 200 milliseconds or something like that. Yeah, let's do that. Okay, so maybe we want to, what is it, let's forget this. The ticker. Okay. So the ticks of a clock at intervals. Okay. Let's just go, like this. And actually, we can just use the time from the channel, so we don't even need this thing. We can just, yeah, okay. So let's do this for T, and for the, yeah. Okay, and then we'll send it through there, and this is just now T. Cool. I assume we can kind of do it like that, but we'll see. Maybe we want to do a count here. Yeah, let's do something like that. So we're going to go here and then well, maybe we can do it for a 5-second thing. So yeah, let's just do it like that. And actually we can just return. Simple. And then we can just document, what this thing does. That's all right. Oh, and actually we can just go ticker.stop. Yeah. Stop doesn't close the channel. Yeah, that's fine. Okay. Alrighty. Let's do that. So then that'll start sending, or should we start playing? We should maybe start playback first and then, yeah, we should start playback first and then, yeah, and then start sending stuff. All right, so let's see how a play thing works. I think I'm going to start a new Go routine. And we're going to read from, so we want a channel. Okay, cool. All right. Let's go something like this. So let's start playback. So we're going to go player dot. I feel like, anyway, we'll just write it and see what it looks like. We might want to refactor it to maybe start playback when we, sorry. Yeah. No, anyway. Okay, let's go. Player.play and then send it through. So all the errors that we, oh, that's it, isn't it? We're just going to do that. Okay, start sending it through, and then now we're going to go read it from errors and then error on each one. Like that. Now, when we, how do we know to stop? Text packets. Let's just run that and see what happens. Oh, yeah. All right. Okay, so there we go. All right. Let's just do this. So we go here, time.sleep, 5 times, and then let's send done. So, oh no, we can just do play.stop. Yeah, and then that should be it. Oh no, that isn't going to finish, is it? Okay, time.after. Sends the current time on the returns channel. We'll do time.afterfunc. But we don't care about that. So yeah, let's just see what it goes. All right, so we're going to do that. We're going to go time.afterfunc. Or is it just anything? Send the, oh, the function is just player.stop, yeah. Whoops. Okay, we've... Oh, we need to close that channel. Who's going to close that? Who's sending the errors? This one is sending the errors. So the player needs to... So when we're done, we need to close that. And we need to close that. Oh, no. Oh, whoops. That goes there. Play.stop. Oh, there are no errors. But it shouldn't... Goes into that loop. So when we do stop, yeah, sends it through done. And then, it's reading here, it's reading here. So we're going to wait until this thing times out and then it'll go into there. So yeah, we're waiting for this timeout, and I don't even know if there's a timeout set. So let's set that. So we know the read deadline. Yeah. So every time we it's getting a little bit messy, but it should be okay. Maybe we'll do the deadline. I'll just do any deadline. Okay. Send that error on the channel. And then we return. Yeah, totally go out. Packets. Yeah. There we go. Cool. There we go. Woo. There we go. Very good. Very good. Oh, that breaks out of the select, not the for loop. I think. Let's do that. Yep, great. Okay. Alrighty. Now we need to tighten all this up a bit. So playing seems to work. What we could actually do here is and actually read, let's log the payload. So here we're reading through the packet, so the player is actually doing that. So let's do that, and then let's just go print Cool. Okay, that looks good. Set it into a string. There we go. Very cool. So that is is this actual time in Australia? Yes, it is. Yeah, cool. Let's get rid of these debug things. All right. It's weird how we're getting a timeout every... It's two... Yeah, maybe like... times 2. How? Yeah, right. So that's 500 milliseconds afterwards. Yeah, it looks good. Very cool. Yeah. Okay. So let's tighten all this up a bit because it needs it. Okay. So let's see. Every time. How are we going to do this? Let's always do a second here. And probably tempted to put a context in here. But yeah, put it in the struct as well, I guess. We've got this stop, but we probably should use a context. It's a little bit more correct, I guess, rather than doing it kind of by hand like this. Sort of like Go before the context package was around. Call this the errors. Oh, no, anyway, let's just leave it like that. Alrighty. Okay, we read a packet, we unmarshal it, and then we send it straight away through the channel. So we've got one thing that's reading from the network, the player, one like sort of thread that's reading from the network, and then the other thread is, let's say, like actually dealing with the payload. So pretty sure that would, probably how a lot of video players actually work, right? Because you don't want to block playback because you're like, reading from the network. So here we'll do our validation. So so we'll do that in a bit. Text packets. Okay, let's tidy this thing up a bit more. So what we want here is let's do that. So that one. Yeah, and then, so, yeah, that's pretty much it, right? Oh, but then it only, yeah, okay. So then maybe we'll do like, and then here we'll do a count maybe. Yeah. So if I is yeah. Oh, whoops, no, it's going to be, yeah, and return. Yeah, every, we'll get some wording for that. That should be all right. Ticker, header is all right. Ticker, okay, yeah, that seems fair enough. So this is like our our source of media, right? It's just this function that just sends stuff through this channel. Seems fair enough. That thing runs along, playback starts, reads through errors. Now, when we're done, make sure that it doesn't send to this closed channel, right? Because this channel will, yeah, that channel will close and text packets won't know about it. So how are we going to stop that from happening? We need to synchronize it a little bit. Oh no, sorry. No, wait. This thing is, oh, have I like just really fucked this up? Probably. Right, because this is the, yeah, okay. That's the, yeah, okay. Hold up. Move, yeah. Okay. These are like the ones that the players decoded. So that should really be like, yeah, We don't want to, okay, maybe we could call this decoded. So then we're going to, yeah, because we've got this, we've dealt with it, we've read it, and then we can just send it through. So then we've, yeah, and then we're on to actually, you know, let's say like, this is the playback. So in a real player, like in a real, you know, media player, this would actually be the thing that would, you know, read in all the MPEG-4 and the frames and everything and draw them to a screen or send them through the send them to the sound card and play a signal. You know, like it would actually decode the signal, turn it into analog something or other. But yeah, we're not doing that. We're just printing the payload text, which works. Okay, so let's do that, and then these text packets. Yes, this is all wrong. So yeah, right. Okay, my bad. Yeah. So this, yeah. Okay. So the text packets needs to send it through, like the well, we actually want to do we want to do that? Yeah. Okay. Start the playback, right? So that's fine. That thing's going to sit there and just wait for some time. So let's put that all the way up here. Now what we're going to have is actually we're going to we don't want to send the packets through the channel. We actually want to send them using our session. So we want to actually transmit packets in wire format to this thing's address. So let's not do this. The text packets actually needs to go maybe errata or something like that, or like a, or really this should be a let's read maybe this thing can just return a channel that actually yeah, that's sending the packets. Let's do that. Blah, 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 blah. Yeah, there we go. Let's make a channel. And that, all of that could go in there actually. Yeah. So again. Okay, blah, blah, blah. Go func there, and then our channel, yep, is there. Cool. and then we're going to return the channel. So that thing will just run along nicely. And then return. Oh, whoops, yep. So we got that, and then that needs to go like that. Yeah. Okay, we'll deal with that in a sec. Okay, let's make sure that we've got our, yeah, so this now is just going to be here. So that's great. Better. And okay, cool. Now we can go this. So these are going to be our, yeah, this is now. Right. And then now we need to set up a session and then transmit every packet that we get from the source. Okay, so let's dial our listener. So ln.local address.string. So how are we going to, what if we error there? I think we can just continue there. Now, when is that going to close? So that, will that, yeah, we'll have to do this ourselves here, right? So this thing's going to be spinning or going away, sending the packets out, and then at some point it'll say, okay, we've done the work now, and because this is the only thing that's sending packets out through this channel, then we're good. So we are going to text packets. Yeah, because then whatever's reading from that will know, oh, okay, time to stop. That's good. So yeah, that's it. Now, once we've got to the end, like once we've sent all the packets that we care about, then I think at that point we're actually just safe to just stop. So how are we going to do that? We've got the text packets. Oops. Sorry. Yeah, text packets, pchan. Yeah. I think that now that once we've transmitted everything, so when we're done here, I think here we can just say, just stop. Yeah, because it's done. Now, there we're going to need to now actually I think that one's okay too, because we can just let's see. Okay, now we need to do our timeouts and stuff. Okay, so how many this? So how long do we want to go for? Let's say 5 seconds. Oh, no. To return to the sentence packets through CH every, yeah, okay. So let's do it every, and then let's do 5. So we're going to send, not happy. Okay. Where are we blocking? So 4P. Transmit that, okay. And then we go back and then we wait for the next one until this channel closes, which it'll do itself after that time, after 5 times per second. Right, yep. Oh, is it because... maybe... I don't know how to do this. Are we getting to here? Three, 4, 5. Yep. Okay. Now that. Okay, here we go. All right, that looks better. Okay, so. Oh, sorry, there's a bunch of messages here. Sorry, I didn't see. We got that one. Yeah, I'm good, thanks. A little bit tired. It's a little bit, nighttime here, and I'm not too good at nighttime. But it's good. It's fun doing this. Won't be doing it for too much longer. I've really wanted to get this working though, so it'll feel good to get it running finally. Hey, Ringo Ma. Late stream. Yeah, it is late. Yeah. Light mode, day 3. It's always been light mode. Yeah, right. Okay, so we're doing that. So is stop not running? Do a timeout here. That'll be good. Oh no. Okay, so we set the deadline because we're probably going to be in here trying to read, right? So if we read from the connection, we're blocking here, and then eventually we're going to get something happened. Let's just see. It's like it never. Huh. Like it never read. Are we not transmitting to the player? We That looks like it works just as I'd expected. So that seems all right. Let's do that. Okay, so we transmitted. Okay. Are we trying to... Player.stop. We're not getting past here. Right, because we're not... Yeah, that's it. So we're blocking on stop. And then... Yeah, okay, it's not even returning an error, so it's just this isn't returning. So we're gonna go, let's have a look at, okay, I do this context thing, don't I? Okay, let's go do that, done. True. Just weird. Like, so the read from, maybe let's doing that. Okay, let's just do, okay. Setting the decoded packet. Okay, we're not getting to here. So it looks like we're getting this thing. I think that's it. This thing is trying to send that's sending, so it's sending the error through the, yeah, and then it's not being read. So maybe, is it blocking on the send? Does it have a block on the send? Am I like misunderstanding the Go? Probably, yeah, because I'm not like, I haven't done concurrency stuff in ages, like a long time. So probably, yeah, there we go. Okay, let's review how this works. So we're sending through this channel, we're sending the error through there, and then we're going to go to, all right, let's keep that, test session, yeah, no, go up to here, okay? So that's where we are, and then if we go to, there, we're not reading, we need to do a select. We need to do a select. I'm going to do it right here. Okay, so we're going to, yeah, this is it. Okay, so we're going to go case, look, I can't remember how to write fucking select statements. That's just, I want the I can't remember. But this is what I'm trying to do, right? I'm going to say, well, look, if there's something from the error channel, then like, do something with it. And then if there's something from here, then also do something with it. Yeah. So then we're just, yeah. So then we'll like concurrently like receive errors from the player, and then but we're also sending stuff as well. So yeah, that's easy enough. Concurrency select. So is C, that's sending on C. Ah, yeah, this one. Receiving from C would block. Yeah. Yeah, that's actually... Just right if no other case is ready. Yeah. Let's just try this, and then we'll do our other case is... No, we're already going to pitch it. No, we're not. Okay, so let's go. Oh no, this is Ishan is text packets, right? Like that. And if we get a packet ready, okay, then let's send it off. So we're going to do that. Let's just keep that there for now. Yeah, that's about it. Now, if none of them are ready, can we do anything? Because we really want to loop through this until... I don't know, until something happens. Oh, well, that's going to... Yeah. Yeah, so I've got the error, yeah. Yeah, so here we, yeah. So really the timeout needs to be, I almost just don't. Let's do that and see what happens. Stopping player. Because we do one, and then we're gonna... How are we stopping? Oh no, of course, yeah. We're again we're blocking because we're not doing here. So let's do this. Okay, so we're gonna keep going on that, and then. Oops. Okay, so when are we going to break out of this? At some point, this channel is going to close and this one is going to close. Because oh, no, sorry. No, it won't. We could tell the player, hey, like only play for this long. So what we should maybe do is say, like all the way up here, let's do an after, after like say 10 seconds, stop. Let's just do 10. I mean, actually, no, make it nice and short, 8 seconds. We've just lost all the time we ever, from waiting there, but okay. So time after finding, let's do this. What do we want to do? We want to, if we get an error, we're going to send it through. Yeah. Like that. That's it. And then we start. And then on the so when we've stopped, that'll close and that'll close, and then yeah, it's good. This is actually good practice. Good concurrent programming practice here. Probably need to model it out a bit more nicely, because there's a few moving parts here and I haven't got it clear in my head. What I'm thinking now is that, say, like after 8 seconds, we're going to tell the player to stop. How do we tell it to stop here? Cool. Few errors on that one. Yeah, nice. Okay. Header extension. What the fuck? Oh, something really wrong there. Okay, that's good though. So when we send time the after hunt. I know. What we can do is let's do a new timer. Yeah, this is it. Okay, so we're going to do a new timer Is that the thing I want? A time, wait, what's that thing called? Not a ticker. I want to, yeah, a timer, yeah. A new timer. And then I'll listen here as well. And if I get, you know, the, if I get something there, then I know that it's time to break out of the loop and just sort of return. That's it. So we only want this here. So here, this is actually going to be, instead of, let's do that. Okay, here is going to be, you know, what's that after? Or just after func? Yeah, okay, so let's do a new time. Like that. Oh, sorry, no, not just that, but actually stop the player as well. That's it. Okay, cool. Get rid of that. Oh yeah, done.c. Oh, there we go. Oh yeah, okay, because it doesn't. Yeah. Okay, so this thing, yeah, we need to let P-chan sort of. Yeah. Okay. Because it's still trying to transmit packets. Let's not do a second because that's like how often we're getting packets. So maybe we'll do. I mean, look, I don't want to have a timeout there. Okay. That's better because our player actually stops sort of kind of when we want it to. Payload, okay. Let's do here, this is actually a play back. Oh no, not play back, it's sort of just a play error. Like that. Or play, or just play. Or, I don't know, maybe like fake, yeah. No, just play. Hi, fake players. Hey. when we get these errors here, play.play, why does it keep, what's this transmitted packet? Why is it? Why is it getting so many packets from there? It shouldn't be getting any, at least not that I'm. Let's just read this in sort of plain English and see what it looks like. So we get the payload type. Okay, we do a ticker that, yeah. Sometimes we want to do it, maybe. Weird. Okay, so every whatever, it'll send a packet through, and then it'll only do that many times before it stops. When it stops, it closes the channel, which it does there. Now, otherwise, it's just going to send a packet with the contents being just text current time, like the timestamp. Text packets. So weird. So when we get an error, okay, so like whatever, yeah, just a weird error that we haven't debugged yet, but whatever. So we transmit the packet and we get an error. No payload. Transmitted packet. It's sending. I just don't understand why it's transmitting so many. Because every time we send one through, we increment, and then, yeah, that's it. And then we should be returning. Three, four. Packet 4. So, hey, we didn't get 0. Oh, no, of course we do. Yeah, we start with, packet. Okay. So, 0, 1, 2, 3, 4. So weird. So we read, we consume. Yeah. What the fuck? Why is this just like spamming packets? It's like it doesn't get there. It sends this and then it never and it transmits it and it doesn't have any errors. So oh, that is that going to make it clearer? It's not. So it's going to transmit. So then it's going to write. So then we're going to fill up the. Yeah, we're going to write a bunch of bytes to the. To the connection. So we're going to send the datagram through. There's no error. Fair enough. Let's do this maybe. And bang. So we're going to get to packet 4 and then we get into here and then we stop the ticker because we don't want any more. Then we close the channel. So we signal to the, maybe we don't close that or something? But I do want to. Times to stop generating text packets. Yeah? Okay, so then it's stop. There might be some behavior of stop that I've like forgotten about or something. So we've got a timer and stop. To ensure the channel is empty after a call to stop. check the return value and drain the channel. Oh, so it... This is a... Oh, no. Sorry. No, wrong thing. We want to look at a ticker. Stop. Seeing an erroneous tick. Turns off a ticker. Fair enough. So we break out of there. We should be breaking out of there. I assume here we're breaking out of this for loop. And then, oh, it doesn't, hold on. The ticker doesn't stop this. Sorry, so when you call ticker.stop, it doesn't actually close this channel. So this break, I mean, I thought that would actually break out of the loop, but it's like misunderstanding it. I don't know. Okay, so then it breaks, and then yeah, I think no more text packets will be generated. Okay, so then this function's done. Done. So this is okay. So there's something else happening. It's not okay. Hold on, this isn't the value isn't being consumed or something. Let's print this sequence number. So the packet header sequence. Oh, P. Three, 4. Transmitted packet. Oh, look, it's still making them. Motherfucker. What? Oh. No, wait, hold on. Okay, so when transmit... I know. Okay, let's make... Yeah, because... Sorry, okay, so no, transmit will still... Yeah, it's something to do with how this thing, this value is being used. Receive text packet from source. Yeah. But that's not necessarily the case. Received, you know, let's read that thing out. So that's going to be the p.payload. Let's do the string of it. (21, 22, 23, 24). And then we're sending empty. Receive payload empty. P-chan. So confused. Right, so I'm in here. Say, okay, that's done. Do I need to close it? Do I need to close this one? Yeah, exactly. Yeah. Yeah, that didn't, yeah, exactly. Let's do this as a, how do you do the receive only? Which way is it around again? The receive only channel is, I forget which way it goes. Why don't I try to close it after the whole loop? Okay. Yeah. Yeah, that's actually clearer as well because we're at the end. Let's do that, and then let's just see what else is happening. Ooh, I forgot about that. Yeah, so we're going to do that, and then so we've stop the ticker, we break, and then we close the channel. So let's see. Close the channel. Oh, okay. Yeah, no. But it's actually it's good because like, yeah, because we have the break there already, right? So like, yeah. So what's happening then is that we've got, it's something to do with, it's here. Maybe we need to do, that's it. There we go. So it's blocked. So it's blocking there. Because something to do with that there. Like when we hit the number of, it's probably maybe this logic isn't super great. Okay, so we're gonna, okay, just like for every time we get a tick, if we, I feel like I still want to send it. Let's just do this. Actually, it needs to be up here, right? Because we always want to send. Like that. And then that tells us if we need to stop or not. Okay, so we've sent that through. We close the channel. If the channel's closed, it's almost like when it's closed, it sends an empty, Like, why is it sending an empty packet through the channel? Is there something that I'm misunderstanding? Fucking, there's something I'm misunderstanding, that's for sure. All right. So let's read this. You don't usually need to close them. Okay, well, fuck it. Oh no, sorry, no. Yeah. No. We do want, when the receiver must be told there are no more values coming. Actually, yeah. Actually, we don't need to, yeah. Because, you know, this doesn't care. It'll just keep trying. Huh. Okay, cool. There we go. All right. So we break out of there, and then where are we going? Received payload. Okay, so okay, so then where are we up to? So we go on. Why are we? Who is it waiting for here? Why is it not getting from here? Because I would expect it to eventually get this. Unless there's an... Maybe again we don't need to close the... Again, maybe we don't need to close the errors. We do want to close that because we want to say, hey, like, you know, nothing more coming. Okay. Now we're blocked here. We're blocking there. We've got to be. That's the only place left. Yeah, let's do that. There we go. There's a timeout. Okay. Ooh, we're close. We're close. We're close. Okay, so with the I timeout, yeah. Then what's happening? So we get, and then we're back to here again. Right, so we set the timeout, we set the deadline. Now interestingly, I don't... Okay. Unmarshal packet. That's where we're going. So unmarshal packet. And we get an error, and then we go, okay, so we'd send the error along, and then we continue. Back up to the top. Okay, we set a deadline. We're blocked on that again or something, are we? And unless we're blocked on the error channel. No, done. It should be. Oh, fuck, so it should be. I'll just return. Let's try that. There we go. All right. So we were blocking on, so we were sending stop and we weren't getting anywhere. So, okay, I think we got it, but this is all a bit fucking wonky here. So I think I definitely need to do some learning. It's been a few years since I really did proper concurrency stuff, which is crazy if I think about it. So we're sending on done, fake player, close the decoded, and then return. Maybe it was blocked on that. Hold on. So let's just see this. Okay. We won't get it here because we're going to get a timeout and then it'll just fail. Yeah, because we're not actually sending the stop signal properly. Okay, there. Nothing. So we're not. Okay, so we get read UDP and then continue. So go back up to here. but we're not. When we're not, it's blocked here. Hold on. There we go. There. That's it. So we're blocked there. And then we're not. Okay, so why aren't we... So we're sending error through. That's blocked. Text packets. Let's go here. There. So this doesn't... yeah, okay. So we're sending that through. Yeah. Okay. All right, I get it. Because we're sending... yeah, okay. We got like a... yeah, okay. We're sending through done, saying, okay, hey, like finish it off. And it goes, okay, fine. It never gets to it. Is that right? Setting deadline. Yeah. It never gets there because it's blocked here. But then it goes, okay, well, it looks like there's like a race. Yeah, I think it's a race condition. Because one's going to try and send the error through the channel and the other one's trying to send through done. Or like you know, like with the stop. But yeah. Maybe it's time to finally dig into there. Stopping player, that's it there. But the player's blocked right here. Well, there. It's blocked there. Yeah, that's it. Okay, so one Go routine's blocked here, the other one is blocked here. Both waiting for each other. So... it's like a deadlock. It's a deadlock. We could try and drain errors here, but I don't really feel like I want to do that because, yeah, it just doesn't feel right to me. This thing, and it can't get the error through because it's blocked here. So how are we going to get the error through anyway? There we go. Now the other thing is that we could set a timeout on the stop. But again, this all feels a bit yucky. Like I feel like it should be like communicated rather than having these like timeouts and stuff. So what about in here? Okay, we try and read, and then if not, then p packet. The other thing we could do is maybe split this out a little bit more. So we could have like maybe, like, I don't know, like have this in, yeah, maybe like have another Go routine that's going to be like render. So, or like handle or something. I don't know. Let's just call like render, just because it sort of sounds like, oh yeah, we're like rendering video, but we're not. We're just doing text. So rendering in our case is just going to be like printing the text. So we're going to read from the just do this thing. And then when we, yeah, exactly, and then do that. So instead of having this in a Go routine, we could just start the render like that. Oops, so start rendering. That's okay, it's happily going to do that. Cool, okay. This makes this a little bit clearer, not indented all the way. So now we can just look and, so this thing's gonna, so this is almost like, this is almost gonna be like receive. Or read even, but anyway. Transmit, receive sort of works, yeah. So, yeah. So yeah, that's fine. This thing could just do whatever it wants. It doesn't matter. We don't. Yeah. And then yeah, because then we're gonna end that Go routine when we close that. So again, coming back to here, how are we gonna handle that nicely? This shouldn't care that it should always be able to send that through the channel. I just don't, yeah, I just don't like that. So the thing, it's really here, isn't it? It should never block on sending an error. So it's like when it stops it, it can't. Maybe this should be here, like that. No, because no, I don't like that. Okay, we got, if it can't read, then it should just send it through, yeah. Then, let me here somewhere. So we stop the player. Player.stop. That's here. You know what? We're already in here. We can just close the channel. Because like that. And then we don't need that. Well, yeah. And then we can say, hey, like, yeah, okay, here we go. If it's time to go, like if it's closed, I can't remember what the error is. Is closed? Might be that. We'll see. Yeah. Are we gonna? Yeah, great. This is actually simpler. As we don't need that. We don't need to select in here. We don't need that. We don't need our channel that's done, because we're just saying, hey, look, if it's time to stop, like, I can just stop. Yeah, we do that and then close if. Yeah. All right, so fake player, don't need to select. Yeah, this is already way better. Beautiful. Okay, let's get that formatted. Let's get our fake player. We don't need the done anymore. And yeah, exactly, right? If it's time to stop, then just stop. And then, oh, I don't know if that's going to work yet because I haven't read through everything, but okay. Oh, there we go. Yeah, fuck yeah. That's better. Don't you love that when things work by just deleting code? That's good. Now, about the closing the channel, I think closing the channel, it tries to, like, I can't remember. I've run into that before. I just can't remember what it is now. But I think that's, yeah. That's it. Yep. It is. However, I want to know more. I'm not going to stop there. Like I want to know. I want to understand at least. I don't want to know. I just kind of want to have an idea or have a kind of sense of when I closed the channel, it was sending through an empty value. Just found that very strange. Oh, that is a great question. I feel like no, I don't know yet, but it's probably going to be like, this is usually going to be one of these things where we're like, we didn't, because the extension is way at the very end of the packet. So, sorry, like at the end of the header. And we shouldn't have anything in there. So I'm not sure what's going on there. And it looks like it just happens to the first packet. So, yeah. So let's go. Where's play? Let's just error there. Let's get rid of all of this stuff. And then that can go. Awesome. Okay. That's looking a lot better. All right. Now we can actually look at the extension. Yeah. Or rather our like our really fucked up packet. Yeah. Okay. So keep our test there. Session. So unmarshal. So the packet that we're sending through is going to have that in it. So I feel like where we need to look is, I mean, that packet to me looks very harmless. Doesn't look like it's got really anything in it that's weird. So I think where it's going to be is in the way that we're, we're going to start here, right? So the text packets, because what's happening is that we're doing transmit, and then the player is receiving the packet, and then it tries to unmarshal it, and it's just like all fucked up. So it'll be in here. And there, let's go through. Marshal packet. So pretty sure it's Marshal. All right. Let's go in there. All right. Header extension. Oh, sorry, unmarshal. Okay. Let's look at Marshall first. So apparently we may be setting the extension bit, which is that there. So, well, it's that bit there. So in our RTP packet, if we look at a diagram of one, which is in, let's just do, yep. Oh yeah, this one, this X for the extension. So apparently we may be toggling that. The other thing that could be happening is that length of 12852. Yeah, because when we're unmarshalling, that's what we're checking. Yeah, weird. There's no... might be that. Let's... that's the first byte. header seems... Yeah, it's weird. Let's maybe... Let's go up a bit. So before, maybe the... I feel like it's must be something to do with the way we're marshalling it. Maybe where... Let's just do this. Hold on. Okay. Weird. Could be something to do with the way that we're managing our byte buffer. So what in our player, I think it is. Yeah. So it could be something in here. Maybe we're not managing it nicely. Maybe we need to, well, unmarshal. Okay, so we're gonna in here. So in here we're getting like a, oh, wait. I know. Yeah. Okay. What's happening is that we are, the read from will read up to that many bytes. The thing is that what it actually reads, that shouldn't just be the thing that we send through to unmarshal, because 1492 is like that, you know, no way. So we need to work out a way to, yeah, basically, like, yeah, that's what's going on. Because we're going to be like, say here, and then we go like, so we read here. We do this. Motherfucker. Well, so much for that theory, hey? I thought maybe there was like a queuing thing or something. Yeah, no, actually, no, of course, because we're only doing one tiny little packet every like second. So there's none of that going on. Maybe maybe there's something in here, unmarshal. Oh, fuck me. Yeah, no, this is wrong. This is wrong. Because ignore till later. No, don't ignore till later, you know? So we're going to go, this is what we want to go. Like this. explain in a sec. Okay, because what's happening is that if we go here, we were reading this, we were reading that value, skipping that one, reading that value, and then I think we even kept going. Yep, so we do marker, payload type, sequence, timestamp, blah, 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 heaps and heaps of things. So we'd read sequence number, and then we'd reslice, and even more, timestamp and the sync source, all of that shit. And then we'd reslice. So we'd throw away all those bytes that we just read. So we would throw away 12 bytes. And then we go, okay, is the extension bit set? But the thing is that the extension bit set, that was like, the extension bit was set in this, zero index byte, which is long gone. So we just happen to be reading some like random byte and seeing some bit toggle, and we go, oh, time to decode the thing. So yeah. I don't know about that. yeah. So that's our problem. So if that bit is set, okay, like we'll just store it and then we'll deal with it later. Now that's actually the same lines of code. Oh, there's our payload. Awesome. Okay, look at this. Yeah, it looks okay. So 57, 58, 59. Okay, cool. Birthday packet, yeah. Yeah, that's nice. Okay, so I think we're... Okay, now we can do some validation. Okay, so if we go back, let's have a look. Oh yeah, here. Okay. So we're sending this over, okay, and we're sending it into here. Now the next bit is to check if it actually makes sense. So we haven't, we want to check the packets and go, okay, well, like, is the sequence being incremented okay? Are the timestamps what we expect? All that sort of stuff. Yeah. Let's start with the easy one. Let's start with the sequence. So we're going to be, so we're going to be reading packets in this, in this function, which I think is also running in its own Go routine. So let's go packet. Oh, no, sorry. No, render. Yeah, this one. Okay. Okay, let's go. So if the previous header dot sequence is not right, like is not the one previous, then something went wrong. Can we send through this channel without fear? Because I don't think we're ever closing it. So we could so we could pass in this chain of errors here as well. Sorry, like this one, we could do it here, I think. Because we're not ever closing it. Yeah. Okay, cool. sorry, that's not right, is if header.sequence, let's get this right. If the header.sequence is not the previous, yeah. I just want this. These lines are so long. Maybe it's, I don't know. Can I shorten them a bit? I'll just do it here. And then let's do that. And then we've got actually this. Okay, so let's just, let's that. Okay. Now we don't expect any errors. Right, there we go. Cool. That's good. That's good. That's good. Something's wrong here. Oh yeah. Okay. So this is pretty easy, right? So if we actually get our, we need to reset the previous. So blah blah blah. If so, and then when we're good, we say okay, the previous equals that. Yeah. Cool. Okay, great. So that's good. Now the player. Now the player needs to know actually the clock rate. I'm thinking that we want to, yeah, I think that we want to set it in here. Because, for example, VLC knows the clock rate that it, f of mpeg also knows the clock rate. So it goes, oh, we're reading in mpeg. Okay, the clock rate is 90,000 kilohertz. Now, yeah, so that's, yeah, that's, so let's work out. Yeah, I'm not sure how to check the timestamps yet, because we don't know how. Yeah, we'll think about that. For now, I'm going to save this, and I'm just going on a quick 5-minute break to get tea and put the heater on and stuff because it's fucking freezing. Okay, so yeah, give me a sec. I'll just set up the little sign I had somewhere. Where is it? Yeah. Oh no, oh yeah, I need to get the little gophers as well. Okay, let me get the gophers, and then I'll set up the sign, and then I'll get tea, turn the heater on, and blah, blah, blah. 2 seconds. Hard to find. There. Cool. Okay. That here. And this. I don't need that. There. Okay. Zoom in. The stars of the show. Look at that. Magnificent work. Looks good. Okay. Oops. Oh god. Oh. Programming is so boring. Oh, the chair? Oh yeah. Yeah, it's cool. Is it something related to web? Yeah. So this is RTP. Just quickly. RTP. RTP is a network protocol for delivering audio and video over IP networks. So that's things like Skype. Nobody uses Skype anymore. Like FaceTime, Zoom, WhatsApp, even regular like 4G phone calls and stuff. They all use RTP to transmit and really to transmit audio and video. So like Google Meet, Slack, they all use RTP. So that's like, in WebRTC, there's RTP under the hood in there, I think, if I remember correctly. So force and that is kind of said, we're doing the instructions from a spec and doing a Go implementation. That's right. Yep. So I'm just reading from the RFC. RFC, what is it, 3550, I think it is. Is it? Yep. So just reading from the spec and that's it really. Just struggling, bit by bit, byte by byte. Yeah. But we've done the doing the tests. Okay, yeah, good question. So initially, how I did it, just to make sure that everything was sort of like kind of making sense, was we would read in from Big Buck Bunny, which if you've ever done video development before, is well known, is this thing. And so, initially what I did was had, we would read that in and we'd use ffmpeg to read from here and write out RTP into our little package. That would actually listen on UDP, and then it would just write it. It would decode, and then decode an decode an RTP packet, encode an RTP packet again, and sends it off onwards to some other player. And in that case, we were sending it on to VLC. And that worked okay. So what we're doing now is we're doing something that's a bit easier to test. So it's not going to be as good as a test as actually playing, audio and video, but it's kind of going to, I want something that's just going to get us like a little bit of the way so that we can iterate quickly and so that, we don't have to do all this manual stuff. Yeah, and that was just to get just to make sure that our code, like all the bit packing and stuff made sense. But to be honest, compared to the other stuff that we were doing, the other binary stuff we were doing, with the other protocols, this one's not too bad. Because, for example, things fit nicely into bytes. Whereas the other stuff, it was like all sorts of, there was a lot of other extra things in there that kind of made up for the fact that, maybe you didn't have RTP, or you didn't even, you didn't know what was on the other end. Whereas this stuff is designed more for like, hey, like you've actually got a computer at the other end somewhere. Whereas with MPEG transport stream and SCSI 35, it was from, the old days where you had like very, very basic devices, things like set-top boxes that, just like, like embedded devices that didn't have, the sophistication of having like TCP somewhere or whatever. But yeah, does that sort of, yeah. So now, we're really only testing we're only really testing like how we manage the header in this high level thing I'm calling a session. So this is a thing that lets you transmit packets. Yeah, exactly. Yeah. There's it's kind of it is interesting too. I mean, MPEG transport stream is interesting because it's kind of these things, they don't have connections. So you just kind of start like blasting packets and it just magically synchronizes and has audio and video and all this stuff. So it's kind of cool. Like it's kind of a lot more like, with like analog audio gear, like you just plug it in and it just starts working. So it's kind of like, you don't really think about anything. So but with MPEG transport stream, like it's got some resilience to, I don't know, it's just interesting. Yeah, it's maybe, what I haven't looked at is Quick. But yeah, I feel like it'll be interesting to see how Quick works, because I imagine that there's going to be a lot of stuff that is in TCP, that's in Quick, right? If I understand, bits and pieces that I've read about it. And the same goes for MPEG transport stream, where a lot of the stuff that you usually have TCP for, or something like TCP, you don't. You just have it in the packet itself. So yeah, kind of interesting exercise. Yeah, so so I kind of just had a quick go at like designing this kind of high level interface. So what this lets you do is that instead of filling out all of the fields in the packet header, you can just dial some address, and then you got yourself a session, and then you just start transmitting packets to whatever the destination is. I think this is a good interface because this is how, for example, if we open up VLC right now, I'm using VLC just because we're sort of visual right now, but I could do the same with FFmpeg. In fact, fuck it, let me do it with the FFmpeg. So the FFmpeg command is, you set some source, let's say for example like MPEG transport. Oh no, we don't even need to do that, right? We can just go big buck bunny dot transport stream, and then we say we want to transport it RTP, and then we just give it an address like 192.0.9. that. So we've specified a source and an address, and then the library, like the libraries in FFmpeg handle the rest. So I felt, okay, that's like a nice high level interface, and I'm pretty sure we could get the same in Go. Because, you know, we've got like, you know, in Go, we've got HTTP GET, for example. So I'm thinking, okay, well, if we can do it with HTTP, we should be able to do it with RTP, especially because RTP is simpler than HTTP. Well, especially if, you know, we're not doing a lot of the stuff that the HTTP package does for you, like, you know, connection management and all sorts of shit. And indeed, we have something like that. Yeah. So that means that what we want is, if we open here, so if we do an RTP stream, or rather, sorry, if we stream something, you know, we have a file, and then where do we go? File. How do you do it again? You do RTP, yeah. Stream announcing. What's this thing? It's buggy. All right. Well, anyway, yeah. But yeah, the point is that, you know, the library can manage it for you, as long as you give it some payload, which we can do. But the only payload we can handle is text, which is fine. Yeah. So the only thing I want to set now is something like the yeah, I don't know. We'll see what the sending decoded packet. Yeah, so this is when I start to look at it and I go, oh, how does this work? One, two, three, four. So why isn't it sending? Okay, so let's go through this just to make sure that when I come back to it later, I'll be sort of making sense. All right, so we got that. Okay, so sending the packet. Okay. So then we're going to read all of, yeah, so we're just going to start the playback. So we're going to, this player's going to start receiving. That's going to transmit. It's like we lose the first one because 1, 2, 4. Yeah, weird. No, we're not. Yeah. I'm just, sorry. This is probably pretty boring, but I'm just reading through it just to make sure that it all makes sense for me. It's pretty late as well, so I'm not feeling super sharp right now, but it's okay. So let's say we start at 0, we send 1 through. 1, okay, go again. Send 1, 2, back up again, then 1. It's 3 now. 4, send another 1. 5, okay. We're going to do this. I find that very fucking interesting. What? Let's read the spec and see what it actually says. I feel like I'm misunderstanding. There, that's it. Look, it tells you right here. After calling close and after any previously sent values receive operations will return the 0 value for the channels type without blocking. Well, there we go. So that's exactly how it's, yeah. Valid receive operations when the channel's closed. Oh, fuck me. Yeah, I forgot about that. Yeah, see, I've just forgotten this stuff. Okay, so all it is here. Okay, so we do really want to close it. Okay, so let's do here. When we're done, we want to close, and then our whatever's reading from it. Yeah, yeah, it's just like plain as day in the language specification. Very clear. So here we want to do this. Let's just see exactly how they've done it. Yeah, it is okay. Yeah, okay. Do this. So if not okay, that means that you know what that means? If we're done, sorry, like if there's no more packets left, we can actually say, hey, like stop playing. Then we don't have to have this timeout. Then everything's synced up. So just like that. And then here, if we're really done, then let's get rid of that. Let's get rid of that. Yeah, I think that's it really. And then we can just return. I hope we're not swallowing any errors, that's all. I'd like to know that that's empty. Yeah. Well, let's break. And then something like that. Cool. Okay. All good. Panic close of closed channel. Ah, interesting. Okay. Oh, something else is closing that. Decoded? Oh, we don't even... Did we not... close of a closed channel. Who else closed it? Huh? Fuck. Closed channel. Decoded. Oh, I know. Because what's happening here is that it's doing close again. Yeah. That's it. So it gets into here and then it goes. Yeah. Okay. All good. So it's happening twice somehow. Maybe I think we're calling stop. So we're doing close and then. Yeah, because we're in the fuck. That needs to be returned. Because we're only breaking out of the select, not out of the... Let's try that. I think. Hey! Go. Now, the only thing I don't like, of course, is that I'm getting like only 3 values. I want to print all, 5 things. So when we transmit, we are, it's going to the player. Okay, yep. So first up, this should do it. So let's do that. Okay, it's 4. It's better. Send on closed channel. That's a good one. Decoded. Yeah, right. So who? Yeah, absolutely. Yeah, this isn't. Yeah, this go routine should call close. Should close the channel. So how are we going to do that? How are we going to know? How does this go routine know that it's time to... Yeah. Does it ever break out of the loop? No. We could... Okay. The simplest thing I can think of here is actually check the error and then see if... So we've got this read from, right? Like, I feel like we should be able to get a good error out of there. So instead of that... Ooh, yeah, let's just do that. Let's just see what this looks like. Nice. Okay. Now that's not quite what I wanted because I want to cleanly stop this thing. So for example, what I want to do is maybe go document and then there's closed. Yeah, that's it. Net close. Yeah, that's it. I want this because I want to say, okay, like if like that, then actually close the stop playing because our connection is dead. Like that's it. And at least in our very shitty player, we're not going to try to reconnect. And yeah, and by closing, all right, I'll just make sure. Yeah, but by closing, yeah. And by closing, that means that we'll stop our renderer from doing its thing. Rendering, like printing text, but it's the same. Yeah, same stuff going on. Sort of. Not really, but anyway. Yeah, so we'll stop our renderer, and then we will... And then what? And then I think we just need to... Or, I mean, really, we could just break out of here, and then actually close at the end or something like that. It's probably... Yeah, something like that. But if we get any other kind of error, like, I don't know, who knows what, let's do that and then keep going. Okay. Yeah, some... Yeah. Okay, just looks a little bit... I don't quite like the look of that, but... Yeah, like really we don't... Yeah, let's see... Ja. Hoe gaat het? Oh. Hey, no truth. Hoi. Sticky Donkey. How's it going? This test is... I'll show you. Ooh. The test that we're running is this function here. So it's just using, and all it's running is just go test. 1, 2, 3, 4. Yeah, I'm not. Yeah. Anyway. like to. Yeah. No, it's cool. It's a cool. It's a cool program written by the lead of the Go project, actually. Yeah. Yeah. They wrote this little program to be used in this editor. Yeah. It's cool. It's called Watch. Yeah, some kind of something better. Now that we've got this stop thing, I mean, I don't know whether. Well, actually, yeah, no. I kind of prefer that interface, just at least for now. Yeah, seems a little bit redundant because, yeah, but yeah. Yeah, so we're gonna go through. So here's our renderer. And I'm a bit tired. I'm not sure if I've ever been not tired. How would you know then what tired feels like if you've never not been it? Day 3, yeah. Did I upload the other day somewhere? I'm curious about it. I implemented it based on Peon or something. El Gordon Freeman. Yeah, yep. That's very philosophy. I don't know what that is. Peon. This is, yeah, I will. They're on Twitch, I think. How do I do it? Video. Sorry, I don't really know how to use Twitch that well. You know, like it has like the videos. How do you find that? Sometimes like a tab and it says, "Oh, videos" or something. Cool. Yeah, nice. Now, and then all the other older ones are on YouTube. So if you want to see, like, because we've done, this is maybe the I don't know how many protocols we've done now, but yeah, if you go to the playlists, I'll link that here just in case. Then you can see all the other stuff we've done: MPEG transport stream, HLS, SCSI-35. Yeah. So yeah, it's been good. Oh yeah, nice. Yeah. Well, yeah, I do it to both YouTube and Twitch just because, yeah, I don't know. I feel like I don't know. I don't know how all the how it all works, but of course we've got a self-hosted stream that is in our little there's down in the. God, I'm so bad at this direction thing. Okay, it's there, like down there, yeah. Oh, nice. Oh, yeah, just doing it, I guess. Yeah, but it's good. Like it's yeah, it's just because I don't have like another chat thing here. So, and as I say, I'm really bad at multitasking. So if I had when I did have the YouTube chat and the Twitch chat, I would get lost, and I didn't know if one people could see the other and all this stuff. Just thinking about how to do a bit more validation here, and obviously we need to check. So we check the timestamp, and then maybe also check the payload. Something like that. Cool. Hey, listen, I mean, that's great though. I mean, like we've actually made like an in-process RTP player. It's kind of silly, but it's a cool approach, right? Because they aren't mocks. Like they're real, like you're actually like sending stuff, you're actually sending like datagrams over the loopback interface and something is actually reading from it. It's just like a very basic implementation of it. But it's enough to, yeah, I don't know. There's no like functions that look like they do something but they don't. I mean, every function does something. And importantly, the actual thing that we're, this transmit, that doesn't change. Or the session. Maybe we could why don't we do this? Like, why don't we bump the thing quite a bit more? Like, let's say instead of sending a packet every second, let's do one like every 200 milliseconds. And then let's do that like, I don't know, 10 times. Holy shit. Three, 4, 5, 6, 7, 8, 9, 10. 20 milliseconds. Let's send 100. Okay. It's good. Are we gonna bump this thing a lot? Every 10 milliseconds, let's send 10,000. So that's 10 seconds. Okay. Yeah, it seems to work. Yeah, it's cool. It's cool, and that's all concurrent, right? So I mean, we could even trading. Here we go. No, it's only Yeah, but that's actually quite good. Like, let's try 5 milliseconds. Yeah, and then let's go let's send 2,000. Okay. Cool. Passes. Very good. It's all right. Why don't we do it every... Let's do a millisecond. We'll do it for 3 seconds. Where are the 0.239 seconds going if you look at the time it takes? Ah, okay. Yeah. Oh, yeah. So there's other tests running, and also there's just there's always like a minimum thing. So like it has to like compile everything, build it, link it, like execute the test, do all sorts of stuff. So what it actually ends up doing, there's like always some overhead. Cool. That runs. Oh. Well, yeah. No, it's not. But when you run the test, it does. Yeah. 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 Ah, that's cool. All right. Well, that's So that's actually I actually kind of like that test. I mean, I think probably I'll set it to something like send every 5 milliseconds, or actually no. So let me think. Like when you do audio, they recommend to bundle it up every. What's the minimum thing that humans can detect? There's a number. Is it 20 milliseconds or something? Like by the time that you can't hear the difference between the sounds. Yeah, but I think maybe something like 10 is all right. No, let's do 5. Okay, and then but then instead of that, we want to do 5 milliseconds, and then let's do 10, 50, 500. So 100 is 500 milliseconds. Let's do 200. Okay, cool. Now, yeah, I don't really want to do that, but oh, interesting. Oh yeah, it does the first one. Okay, yeah, there we go. Cool. All right, that's pretty good. I think think that's it. So we can actually just dump all of this stuff now. There's all that, and that, and that, and that. We can go. Yeah, we could be really pedantic and like do all sorts of stuff, like check the versions and things. Sync source, yeah, we should check that. Let's grab that. Let's grab that. So when we actually render it, we need to check that the sync source is the same. Because if the sync source is different, then like, well, you know, what is that? Does this get sent through the channel? Okay, yeah. Okay, good stuff. Yeah, we'll go through that. So we'll go check the version and everything. Okay. Cool. And then just see the other things we can check. Oh yeah, the payload type, yeah, all that. Go to the header. Yeah, okay, so we'll need to do that as well, yeah. Okay. Cool. All right. Well, hey, look. I mean, we did it. Holy shit. Yeah, that's pretty good. Like, so this is, I guess the next things that, well, other stuff that might be interesting is to, like, try and break the player. So, for example, what we want to do is like just send like totally broken shit, like timestamps that are in the past, sequences that are, you know, like way out, sync sources that change, all that sort of thing. Now the player, okay. Now that said, I mean, we don't really care so much about the player having a really robust implementation because it's not the player that. Sorry, you know what? I actually take that back. We don't want to do that. We want to. What we're really testing is whether our transmit, like, well, whether our session is behaving as we expect it to be. So, yeah. Query. What is the best way to connect to SQL database at the beginning question? One, using Go, using plain SQL, using plain SQL module plus driver. Yeah, I think. Look, to be honest, I have barely done. This is going to sound funny, but like I've barely done any work with relational databases. When I have, it was only just using SQLite. So for me, for those use cases, using like the SQL package from the Go standard library, and tried a couple of different SQLite drivers, but yeah, that they were totally fine. So yeah, maybe it depends on the project. So it depends what other people are used to. Are there other projects that are using a ORM? Yeah, there's a whole bunch of things. I didn't use an ORM because it was a pretty small application that was going to be running in a kind of a, in like an almost air-gapped network. So it didn't, and I knew that it was just going to be, once it was done, it was just going to sit there for like 2 years or more even. So and it was really never ever going to change. So using an ORM for that, it was like, didn't really, and people that I was working with, like me, there was only like 1 or 2 of us that were even writing the code. So it was kind of more important just to have like plain SQL so that at least they could go in and read it. The other people weren't programmers. So, yeah. Hey, how's it going? Hello. Oops. Yeah. Does that, I hope that's helpful or something. Yeah. I would probably, yeah. If it's the first time using a database, I would probably say try and use SQL, just because then, that's all that happens under the hood anyway. So if you can get by just with SQL, then I think that's, yeah, that would be cool. Yeah, maybe just try SQL because well, why I say that is because the knowledge, like if you learned SQL, then and got really familiar with that, then that's a skill that will last a very long time. But ORMs, depending on the language you're using, each one has different features, different syntax. Yeah, they're not necessarily portable between languages either, right? Things change, the interface changes as maybe the ORM updates or something, all sorts of stuff. So, yeah. Yeah. I would say, I think learning SQL is always going to be really helpful. I'm pretty sure in the Go documentation, they have, is there a database? That's from the official Go documentation. Probably a good place to start as any, I guess. Yeah. Why is everything a struct in Go? Well, it's a hard one to answer why. But you know, a struct isn't like yeah. I guess a struct is, you know, it's sort of like this, right? The ADT, you know. But if you think about it, right, like it's just a way of, I suppose, like grouping together the core types. So, yeah, int, string, byte, rune, channels. Yeah. I guess it's just a way of naming things, in a sense. I mean, there's so many other reasons to it that, but yeah, probably wouldn't. Yeah. All right, look, I think I've kind of looked at this long enough. So probably what I should do is just do a very quick bit of documentation for the session, and then, you know, I'm not sure if this is really going to be the best way to. Yeah, not quite sure how to do this, but let's yeah, let's do and then transmit. Here we go. We'll do this as P, but yeah. So encodes probably from there. So what we want to sort of explain here is how in the packet header, the session is going to manage a whole bunch of that for you. I'm just not sure how to write that. We'll automatically set, like, you know, we kind of want to, I don't know, need to get some nice wording, but the session will we could probably put that here. Yeah, I don't know. I can't quite get it. I'm a little bit tired. So what I'm going to do is I'm just going to save that stuff. Let's just have a look just quickly just to see what I'm kind of looking at here. Yeah, because that's going to be... I might have a look at the... at the HTTP package documentation. I'm going to look at the request and client types, and I'm going to look and just see how they've documented, like how how that stuff is automatically managed. So, you know, for example, like when you do a HTTP post request, then, you know, you're not like the HTTP package will automatically set the content length header for you, which is handy. So I just want to see how they've documented that and where they've documented that in relation to, you know, yeah. So, yeah, let's. I'm gonna call it because it's almost midnight here in Australia, and yeah, I'm tired. One more question. Sorry, if I get how do I go to define in editor Acme? Do you mean first up? I'm gonna say goodbye on YouTube because that's the first thing to do. Okay. Got it? Yep. Okay. Good night from Australia. Good morning or good afternoon, wherever you are in the world. I wonder where in the world it's the morning right now. Yeah, anyway. See you next time. Thanks for watching. Ciao. Okay, cool.